Hello everyone, this is Rajorshi, and today we are going to solve the problem which is known as valid anagram. It's the problem leak code 242, and it consists the category of lead code easy. So let's directly jump into the problem description and what we have to do now. So we are given two strings S and T, and now we need to return true. That means a Boolean value if T is an anagram of S. That means a rearrangement using all the original letters exactly once. And this question is asked in these many companies. So now, what is an anagram? So let's first of all let's understand this. So we are given a string, this one, and we are given another string, and we need to arrange all the characters of the string, and we have to find out lastly that if all the characters are the present in both of the strings in the same frequency, then those two strings are anagram. So for example, we can say that A, B, C and string CAB both are anagram because each character repeats only doesn't repeats in the true string, and if we rearrange all the characters then we are going to get the same output. So ABC and CAB are anagram. So here, how we can solve this problem? So the first and foremost brute force approach will be just sort uh, just sort the both of the string lexicographically. That lexicographically means how the uh, dictionary is sorted. That means first A comes, then AA comes, then B comes, BA, then BAB. So this is how lexicographically sorting is done. So what will be our brute force approach? So brute force approach will be just to return the sorted of S and sorted of T. If the sorted of S and sorted of T gets us the same output, then we can say that it is a valid anagram. That means if we sort A, B, C lexicographically, it will return us ABC. And if we sort CAB, it will return us ABC. And if we compare these two strings, it will return us the exact same value. That means we can say that these are uh, anagrams. So first brute force approach will be that we need to return sorted of S and sorted of T. It will uh, give us the right answer with the time complexity of big O of n log n and space complexity of big O of n, because lexicographically sorting takes big O of n log n time complexity. And as we are using two extra spaces with constant size of n, where n is the length of the strings, that's why we have a space complexity of big O of n. So as you can see that our test case is passed successfully. Now we are going to see the optimized approach to solve this problem. So let's start the animation. So this is the brute force approach that is going on. So let us wait for a second. Yes. So here, where's the solution? Right. So here, what we can do is, first of all, we have to check for a condition that if the length of the string S and the length of the string T are not same, then we don't have to check any further condition and we can directly return false. This is the first and foremost condition. Second thing will be we need to use an extra data structure to store the frequencies of the particular string, particular given string. So first of all, we need to use a hash map to store the frequencies. In the hash map, we are going to uh, traverse the array, traverse the first string first, and then count all the frequency of each and every character. So let me show you through the anagram animation. Yeah. So let me write. All right. So in this case, we are initializing a hash map and we are traversing through the string and counting the frequencies of the hash map. So in the first iteration, I equals to 0, we are getting the value of first character of the string, which is A. So we are counting the frequency such as A equals to 1. Then in the second iteration, we can find N. So our hash map will be A equals to 1, N equals to 1. In the third iteration, we can find the A appears again. So we are just incrementing the value of A. So A will be 2, N will be 1. And this is how we are going to fill the entire hash map with the frequencies of the first string, that is S. So after the iteration ends, we will have something like this. So for this particular test case, we have A equals to 3. Frequency of A will be 3. N will be 0. Y, N will be 0. No. Right. A will be 3. N will be 1. G will be 1. R will be 1. And frequency of M will be 1. So this is all the characters. That means the total number of characters is 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1, 7. 1, 2, 3, 4, 5, 6, 7. Now we need to traverse the string 2 again. So we are traversing through the string 2 and we are just uh, decrementing the frequency of each character of each frequency of the respective characters. So in the first iteration of t, we are going to find that t of I equals to a. So we are just decrementing the frequency of a. So it was a equals to 3, but it is now a equals to 0. A equals to 2, what I am saying. Then the entire thing will be done in the same format. And at the end, if it is anagram, then the hash map will return. The hash map will contain each characters of the string t with a frequency of with each contains a frequency of 0. And now we are checking for a condition that if count of C, that means total element, are less than 0, then we are returning it false, because this is the condition that we are checking for. And if all the conditions are satisfied, are uh, uh, the conditions that we are providing, then we need to return true. So this is how we can find a string is two strings are anagram or not. And let me jump into the code. So first of all, we need to check if length of S is not equal to length of T. If this is not the criteria, then we just need to return false, right? And if this condition satisfies, then not satisfies, then we need to return we need to create a hash map. So let me name it count. It's a hash map. And then we need to traverse the first string. So for CNS, then what we need to do, count of character. So C means the each and every character of the string. we need to plus it. That means we need to store all the frequencies, right? So our job is done. Now we need to traverse the second string, that is for character in T. Then we need to check for the same uh, criteria, but in the negative decrementing order. So count of C will be minus minus. And under this loop, we are going to check for a condition that if count of C less than 0, then just return false, else return true. It should work. Let me evaluate it. Our AI is running. It's taking a lot of time. Yeah. And we have successfully solved the problem using a time complexity of big O of n and a space complexity of big O of 1. Right. So let me directly jump into the lead code. So this is our problem, where in the second approach, we are just checking the length of the T and length of the S is same or not. If it is not same, then we are just directly returning false. In the second step, we have created a hash map of character and integer to store the frequencies. Then we are traversing through the first string, taking each and every character. And by this method, we are just storing all the frequencies. Then we are traversing through the second string, picking all the characters and checking for this particular condition that if this particular character is not present in the hash map or its frequency is less than 0, then we are just returning it false, or we are just decrementing its frequency with respect to that character. And if each and everything doesn't works, then we are returning true. So now let me run it. It runs successfully. Now let me submit it. Okay, so I got a mistake. What is the mistake? I think here it will be less than equal. I made a mistake here. Mm, yes. So we have successfully solved and submitted this uh, problem, and we have now successfully solved the problem valid anagram. So this is how we have solved it. And thank you for watching this video. Tomorrow we are going to solve a new problem present in the DSS sheet. Thank you very much.